We're going to find areas of circles. Then we're going to find areas of sectors of circles. All right, so let's see. Let's turn to page 782. And on 782, they're going to explain to us how we find the area of a circle. We've already learned that the circumference of a circle can be found by saying C equals 2 pi r, because you can use this formula to develop the formula for the area of a circle. So they give us a figure here of a circle with radius r, and they call the circumference c, so they're using letters the way we're used to them being used, r for radius, c for circumference. And they divide it up into these congruent pieces. These pieces are going to be called sectors, okay? And then they rearrange them, all right? So they take the pieces of the pie and they put them together like this, and so you get something that's really close to being a parallelogram. And if you made, let's say 1,000 sectors instead of the, 15 or 20, however many they made, wouldn't that be even closer to being a parallelogram? Because each little slice would be narrower, so there wouldn't be as much bump to them, not as much curvature to the edges. All right, instead of 1,000, let's make it 1,000,000. Instead of 1,000,000, let's make it 1,000,000,000. Instead of 1,000,000,000 pieces, let's make it 1,000,000,000 raised to the trillion. Raised to the trillion. Raised to the trillion. It'll be a parallelogram at that point, won't it? It will be completely, utterly indistinguishable from a parallelogram. Well, we already know how to find the area of a parallelogram. It's base times height. Okay? So, look, the top base up here is half the circumference because the bottom base down here is the other half. So the base of the parallelogram is half the circumference. And then what's the height of the parallelogram? Well, it's the original radius. Okay? So if you multiply 1/2 C times R, you get the area. Well, what is C? C is 2 pi r. So what is 1/2 times 2 pi r? Well, it's pi r. What is pi r times r? Pi r squared. Did you follow me on all that? So that's how you get the area of a circle. Area equals pi r squared. Okay? Any questions on how they came up with the formula? I think it's kind of cool. Let's see if we can use it. Page 784, number 1. Find the area of each circle, round to the nearest tenth. So, we'll round it to the nearest tenth. We know our formula, area equals pi r squared. There's only one thing we have to know to find area, and that's the radius. Okay? So it's not like some of the others where we would have 2 diagonals or 2 bases and a height or a base and a height. Radius is all we need. So for number 1, the radius is 21 yards. So that'd be pi times 21 squared. All right, so let's see. 21 squared is 441. So it's 441 pi square yards. But they do tell us to round to the nearest tenth. So if the directions call for an exact answer, that's the exact answer, 441 pi. The answer this set of directions call for is to the nearest tenth. So 441 times pi, and to the nearest tenth, we'll get 1,385.4 square yards. Okay? We okay with number 1? All right, number 2. Now, number 2, they don't give us the radius. What do they give us? They give us the diameter. So if the diameter is 0.4 kilometers, what's the radius? 0.2 kilometers. Now we've got the radius. We're back in business. Area equals pi r squared. So that's pi times 0.2 squared. All right, so if I take 0.2 and I square it, I get 0.04 pi square kilometers. But the directions did say to the nearest 10. So take that 0.04 times pi, and to the nearest 10th, I get 0.1 square kilometers. Now, at first this may strike you as a little odd. The diameter is 0.4, and the area is actually smaller than that. Is that okay? Yeah, it's okay for a couple reasons. One, it's different units. It's square kilometers, not a linear measure of kilometer. And two, isn't that what happens when you multiply by a number between 0 and 1? Don't you get a smaller result when you do that? Well, that's what's going on. We took a number between 0 and 1, the 0.2, and then we squared it, which gave us an even smaller number. And then that times pi, so we're multiplying pi times the numbers between, well, that's almost 0, okay? So yeah, it's just going to keep getting smaller. All right, we okay on 1 and 2? Those kind of easy? Yeah, they're supposed to be. All right, number 3. Find the indicated measure, round to the nearest 10. So we're supposed to find the diameter of a circle that has an area of 74 square millimeters. All right, so like we did with the other area formulas, it's a little more interesting when they tell you what the area is and they ask you for one of the other measures. The only other measure they can ask us for is the radius. Oh, wait, they ask for diameter. Yeah, because once you get the radius, it's easy to get the diameter. Okay? So all of these are going to work out just about the same. So area equals pi r squared. Replace capital A with 74. And then solve it for the radius. Once we get the radius, we can get the diameter. Now, if they were really tricky, they'd ask us for the circumference, because once we got the radius and then got the diameter, we could get the circumference. So here we go. Divide by pi. So whatever 74 divided by pi is, that's r squared, isn't it? And don't use your calculator yet. There's no need to. You don't need it yet. Now, what do you do to get the radius? Take the square root of both sides. So the radius is whatever the square root of 74 divided by pi is. And since our area was in square millimeters, our radius will be millimeters. So, as unattractive as that answer is, that's our exact answer. Now, they do want it to the nearest 10. So let's see. Now it's calculator time. So let's do the square root of 74 divided by pi. And the radius is, I'm going to write down 4.8, but I don't mean it. I don't mean it. Don't round yet, because they want us to get the diameter. Okay? So don't do the rounded off radius times 2. Do what's on your calculator times 2. A lot of the time, it won't make any difference. Some of the time, it will. It does here, doesn't it? Okay? So 9.7 millimeters is our diameter to the nearest 10. Number 4. The area of a circle is 88 square inches. Find the radius. Go. Get what I got? Okay, everybody's able to come up with 5.3, and it's inches, isn't it? All right, so like I said, about the only other thing they can do on these questions is they could ask you the circumference, which I kind of wish that maybe there is some in the assignment that do that. They ought to, right? Find the radius and or the diameter, then you can get the circumference. All right, now we're also supposed to be able to find the areas of sectors of circles. So we need to know what a sector is. And a sector is that slice. You know, when we developed the area formula, we did it by making those slices. So a slice of a circular pizza is an example of a sector of a circle. So a sector of a circle is a region of a circle bounded by a central angle and its intercepted arc. So if you look at the picture here, here are the sides of the central angle. When it says bounded by, it means they're telling you what the boundaries are. So the boundaries of the sector are the sides of the central angle and the arc intercepted by that central angle. Those are the boundaries. So the region enclosed by those two segments and then that arc, that's the sector. The formula for the area of a sector is similar to the formula for arc length, because isn't that sector simply some fraction of the circle? And so isn't the area of the sector some fraction of the area of the circle? Got to be. All right, I like my version a little bit better than I like the book's version. So here's what I want you to write down for the area of a sector. The area of a sector equals M, meaning the measure of the central angle, or the measure of the intercepted arc, because they're the same, right? Divided by 360. So that's your fraction of the circle, because the whole circle is 360 degrees. So our sector will be, 100 degrees out of that 360, or 50 out of that 360, or whatever it happens to be. And then so that gets you your fraction of the circle. So then that times the area of the circle. Okay? So the measure in degrees of the angle or the arc over 360 times the area of the circle. Let's do a couple. Number 5. Find the area of the shaded sector, round to the nearest tenth. So we remember that our formula up there. So the area of the sector equals the measure of the central angle in degrees or the measure of the intercepted arc in degrees. So 57 over 360 times the area of the circle. Well, they give us the radius is 3, so the area of that circle is pi times 3 squared. Okay? Now, they tell us to round to the nearest tenth, but I want you to be able to get an exact answer first. Okay? So, leave the pi alone for a minute, and let's get a fraction for multiplying 57 over 360 times 3 squared. And I know 3 squared is 9. So let's do this. Let's do parentheses 57 divided by 360, close the parentheses, times 9. And let's have our calculator give us that as a fraction. So math, fraction, enter. Okay, wow. That reduced more than I thought it might. I guess I should have seen that 9 is going to divide into 360. So yeah, that makes sense. So 57 40ths pi inches squared is the exact area of that sector. Now, your calculator may not work the exact same way mine does, but try, if you can, try to get a fraction times pi. Okay, if you can't, then you can't, but try to. Now, let's give it to them as a decimal like they said. So let's take that 57 40ths times pi. What did they say, nearest tenth? So to the nearest tenth, that'll be 4.5 square inches. Okay. Do number 6. You get what I got? All right, so we're still doing okay. Any questions? All right, we ready to move on? Number 7. Chelsea is baking pies for a fundraiser at school. Now, I got to admit, I really like pies. That is the most unappetizing picture of a pie I've ever seen in my life. I mean, really? Think of all the good pies they could have had a picture of, and they chose that. I don't get it. So, she divides each pie into 6 equal slices because nobody could eat a fourth of that. What is the area in square inches for each slice of pie? All right, so let's do part A first. All right, so each slice is going to be a sector. So the area of the sector equals. Now, I want to deviate from our formula a little bit. That m over, that was so that we could figure out what fraction our sector was of the entire circle. I don't really need to know what the measure of that central angle is if I already know what fraction that sector is of the entire circle. And if she's cut it into 6 equal slices, isn't each slice 1/6 of the circle? So I get to deviate from the formula. All right, instead of m over 360, it's 1/6 of the circle. So the area of that slice is 1/6 of the area of the circle. So 1/6 times pi r squared. Now, if the diameter is 9, what's the radius? So 1/6 times 4.5 squared. Now, let's get this as an exact answer first. So if I take 4.5 and square it, and then divide it by 6, I get 27/8. So 27/8 pi square inches. Do they tell us what to? They don't tell us whether or not we should round it, do they? All right. So I've got my exact answer. I'll give them to the nearest tenth as well, since that's what all the others were. So take that 27/8 times pi, and we'll get 10.6 square inches. All right, part B. If each slice costs 25 cents to make, and she sells 8 pies at $1.25 for each slice, how much money will she raise? Okay, let's figure out what her costs are. If each slice costs 25 cents to make, and then there are 6 slices per pie, so the cost per pie then are 25 cents times 6. And what is that? $1.50. So it costs her $1.50 to make each pie. All right. I'm going to assume that she made 8 of them since she sold 8 of them. If she made 100, well, then everybody else thought the same thing we did about the pies. Okay, let's assume she made 8. So then her total cost will be 8 times $1.50. What's that? $12? So it costs her $12 to make the pies. Now let's see how much money she gets. So she takes in, okay, what was it? She sells 8 pies for $1.25 for each slice. So per pie, she takes in $1.25 times 6. So $7.50. So in total, if she makes 7, or if she brings in $7.50 per pie, and she sold 8 of them, what's $7.50 times 8? 60 even. All right. So I think they worded it, how much money will she raise? Which I'm going to call that her profit. So isn't her profit then $60 minus $12? $48. Okay? Are there any questions over the areas of circles and the areas of sectors? In a minute. Let's get started on this. Page 784. Do 1 through 24, 27 through 30, 32 through 38, 40, 41, 44, and 50 through 53. I'll do it on the recording. Which one did you want to see? 27? And I'll put this back up in just a minute. All right. 27 says the area A of each shaded region is given. Find X. All right. So it's a sector. All right. We know that the area of the sector equals M over 360 times the area of the circle. So let's fill in what we know. The area of the sector is 66 square centimeters. All right. What's the measure in degrees of the central angle that makes our sector? 180. So I'll go ahead and put 180 over 360. But we could have kind of bypassed that. When we see that it's a semicircle, we could have just written half, right? So 180 over 360, which I'll change to a half, times then the area of the circle. Okay, and here's where it starts getting complicated, right? Because what's the radius of this circle? 1/2 x. If the diameter is x, then the radius is 1/2 x. So the area of the circle is pi times 1/2 x squared. Okay? Everybody with me? All right, now don't get in too big of a rush to go to your calculator. We've got 66 equals 180 over 360 is a 1/2. I'm going to put the pi at the end here. No, I'm not. I'm going to ignore the pi for just a moment. 1/2 x, when I square that, that means 1/2 x times 1/2 x. What's 1/2 times 1/2? So that'll be 1/4, and then x times x is x squared. And actually, let me put the x squared at the end and the pi right there so I don't forget it. Okay, with me? What's 1/2 times 1/4? So I get 1/8 pi x squared. All right, now, again, let's not get over anxious here. I could do the next thing I'm going to do in one step. I'm going to do it in two, so you'll be sure to see what I'm going to do. I'm going to get rid of the 1/8. I'm going to multiply the left side by 8. I'm going to multiply the right side by 8, because that way on the right side I'll just have pi x squared. And on the left side, I'll have whatever 8 times 66 is. So 528. All right. What do I do next to get that x by itself? Divide by pi. So 528 divided by pi equals x squared. And what's the last thing I do to get x by itself? So x equals the square root of 528 divided by pi. The directions don't tell us whether we're supposed to round it or not. They don't say find the exact answer for x. They don't say round it to the nearest tenth. So there's our exact answer. What's our unit here? Centimeters. And then they've been asking us to the nearest tenth, so we'll give them that too. So the square root of 528 divided by pi. And so, what is that to the nearest tenth? It's 13. All right, because look, I've got 12.96. The 6 tells you to round the 9 up. Well, if it becomes a 10, then that's got to be a 13. So 13.0 to the nearest 10. And that ought to help you a little bit on those tough ones.